Well, I'm not sure who else is going to show up. I went and had him announce it again, but
hey, we're here, so you can start.
yeah. Why wait? I'm going to talk about history of ham microwave to start off with, and being such it's a small crowd, we at our club meetings we usually introduce ourselves and we'll go around the room. I'm Steve, KE5O.
I'm Kelly, KE5O.
John, KF5J.
Ray, N5KIR.
Stephen, KA5OHK.
Pat, ND5C.
Johnny, N5NED.
Bo, KT1AA.
Paul, WA5UNJ.
Yeah, and this is my ex-wife, Leah. So thank y'all all for coming. I was just going to step into some of the history. Retired from GSU Entergy after 42 years as a microwave technician. And we also played with it as a hobby. WA5JMZ, Paul, he's here. He lives in Huntsville. Another guy that worked up there was WA5EFI, Vic LaRocca. He lives in San Antonio right now. But we all played microwave back then, and we kind of transitioned from the old stuff to the new stuff. And you can imagine it started out as early as the late 1940s or into the 50s. Anybody recognize what this is?
Yep.
You should.
I got a couple of them at the house.
This is a klystron tube. It generates 10 gigahertz with the proper voltages applied. This is a little coaxial tail that comes out of the bottom of it with a probe to put in a waveguide. This was used as a local oscillator for a 3-centimeter radar in World War II. So a lot of these were available surplus market post-war.
This got the little bands on the side that you can tune it.
Yeah, they had tunable magnetrons back then too. But this one, the way this works is you've got a little bitty scissor jack on the side of it with a screw to adjust it. That actually moves this top part up and down, and with extremely close tolerances inside, it adjusts the frequency. So by adjusting the voltage and the mechanical tuning, you could put it over a fairly wide range. The radars worked at 9 gigahertz, but they easily tuned up to the ham band, 10 to 10.5 gigahertz, or KMC, as they used to say back then. Anyway, the other thing that you needed was a crystal detector, like a 1N21 or 1N23, looked like that, and you were in the microwave business, playing with it. I'll show you what they did back then. We actually built one of these, and it worked. Oh, thank you. Keep it from going to sleep. Back then, this is from June of 1963, QST built what was called a poloplexer. And sometimes you could use an orange juice can. This was at 3 gigahertz. So this would have been a klystron tube used by the Western Electric long line microwave equipment. Dealing with waveguide about that big around. You'd stick the klystron in one direction, and then you would, at 90 degrees, you would put in your detector diode and provide your isolation from your local oscillator / transmitter to your detector diode. And the station at the opposite end would rotate his transmitter 90 degrees to yours to line up with your detector diode. And you could use it feeding a dish, operate this thing 20 or 30 miles. And the klystron 2 put out maybe 250 milliwatts, Anyway, y'all can pass that around and look at the diode in the klystron. Oh, didn't want to do that. Okay. Yeah, this was from another, oh Lord, website describing how to set up a poloplexer with an external oscillator. If we're going to play at 10 gigahertz, you're probably going to use 1-inch copper water pipe as your waveguide. And you can put a probe in at 90 degrees with a screw to adjust the local oscillator injection between the two. And then you were in business. But around 1976 or 1977, Microwave Associates came out with a ham radio product called a gunplexer. The gun diode oscillator technology was pretty mature at that time, and you could buy the gun diode oscillator and mixer, which included a mixer crystal just like the one you're looking at, and a little circulator, a ferrite circulator, for about $100. It seems like it was a lot more back then, 40-something years ago. I was just walking outside around, and somebody was selling a 1982 handbook, and they have a picture on the front cover of a guy operating a gunplexer on a camera tripod on top of a hill on there. I said, hey, I need that for my show and tell. And that's exactly what's in here. This is a little gunplexer module inside here. It's tuned up on 10.368. And you can put together yourself a receiving setup. It drifts, so you have to readjust it, but it is transmitting right now, and you're going to set yourself up a real inexpensive receive setup. You can buy this European style down converter, which has an extremely stable oscillator in it, for about $30.
Yeah, it was about $30.
Yeah, and you could buy this thing. You could from a ham in the Ukraine, but he's not selling them for some reason right now. And it will convert the IF frequency, which happens to be 618 megahertz, down to 145 megahertz, which you can look right here. I don't know if you can see on this 705 spectral display, but almost right up on 145 megahertz. Let's see if I can. See, I can hardly cover that up with my hand. There's so much gain. But you see the signal on the front. I can turn it off, and it goes away. Turn the volume back up. So with just a DC injector, this, and a radio that'll tune, like my little Kenwood Handy Talkie, to 618, you have a 10 gig receiver. So if you got that, you got an antenna test range. Put a step attenuator in between, you can calculate antenna gain. So it's something to play with and document right there. Again, this and this is optional. You can set that up to receive.
Is that the converter you said?
This converter right here takes the IF frequency using one of these cheap down converters, and it brings it down to 2 meters so that you can, whatever we. If you look the guy up on QRZ, it says address is hidden. So I don't blame the guy. But anyway, one of the things that you could do back then, you can see the crystal inside here. This is a 10 gigahertz door opener where you walk up to the grocery store and the door is just open. This is a Doppler motion detector, and it works on as you are moving toward or away from a signal source. This is a gun oscillator in the back. Signal goes out the end, comes back and mixes with the outgoing signal and produces an audio tone that you could, detect, and that's what tells the doors to open in there. But you could also make a radar, not a radar detector, but an actual radar to put in your car so you could determine your speed.
Stevenson did that.
Anyway, these were available at Hamfest all over for like $10. There you are, your own 10 gigahertz with one of those. Not exactly narrow band or frequency stable, but it would get you on. So those are pretty inexpensive way to do it. Again, this is stuff like we played with at work when we had time. You can manufacture your own horn. That's just sheet copper. This is a homemade transition using a piece of old WR90 waveguide cut off with a back soldered on it and a SMA connector with a probe inside. And makes a good antenna. We were playing around back then and actually came across a 1970s era C-band low noise amplifier. It was a parametric amplifier. A parametric amplifier is just a diode that is pumped with a frequency about 10 times as high as the one you want to amplify. And so this was a C-band 4.2 gigahertz. The pump oscillator was this device right here at 48 gigahertz. So this is 48 gigahertz waveguide coming out of the top. So we made this little rectangular to tubular adapter right here. This is a detector diode. This is just a attempt at a guess at what the feed horn should be, and we made it adjustable right there. We actually made this work across a room. That's apply 6 volts and 48 gigahertz of RF comes out. So now we didn't make any DX records with it, but we were actually can say we were on that band. And there's all kinds of things you come across at the Hamfest. There's a guy that is just a genius at microwave. Kent Britton, WA5VJB, is up in Dallas, along with Al Ward, W5LUA, who has like all kind of records set. He makes these printed circuit antennas, and they're incredibly affordable. There's a 1296 Yagi, and this is called a Vivaldi antenna. You'll see there's also one of those in that factory horn over there, extremely broadband, 1.5 to 15 gigahertz. And I'll show you just how expensive they are. No. There we go. This is his website, Kent Britton, Kent Electronics. And he makes microwave antennas. Okay, that's that one right there. $14 without a connector, $29 with. So, and it has a fair amount of gain. Again,
1.5K to
1.5 gigahertz to,
1.5
to
gigahertz,
15 gigahertz. And it exhibits a decent amount of gain. But we had access to test equipment, spectrum analyzers that went to 18 gigahertz, you know, and stuff that I no longer have access to. But the Chinese, God bless them, have come out with some very affordable home use test equipment. And one of the most amazing things is this spectrum analyzer that they've got called the Tiny SA, the Tiny Spectrum Analyzer. And you get it, the Tiny SA Ultra, you enter the secret code and it goes extremely wide band. I can sit there with, it's got a little pick that you can use if you don't have a good fingernail.
You figured out why they used that code? When they bothered?
I don't know why they bothered to do that. You can see it anywhere. Yeah, the secret code you enter and it's like
1, 2, 3, 4 backwards.
yeah, it's kind of like, you know, widebanding your ham radio, you know, but it's more open than that. I don't know. I'm entering directly 10 gigahertz start frequency, stop frequency 10.5 gigahertz directly, and let me grab this waveguide transition and connect it up to the spectrum analyzer. That little baby's on over there. And there it is. And it's reading at the top of the screen 10.368 at minus 50 dBm. It calculates for you. And let's see, it might pick up better with the, it picks up real good with that Vivaldi. Put this horn on there. Yeah, that picks up really well. You ought to be able to pick this up anywhere in the room. Just aim the horn at that little transmitter. The transmitter's putting out about 10 milliwatts. It's very low power. Let's see. This is probably about a 20 dB gain horn. Hamfest special from 30 years ago, 40 years ago. And the test equipment you can buy on eBay is very affordable. This is like $60. This was like $50. The signal generator, crystal controlled up to 4 gigahertz. You just direct enter the frequency. This is a touch screen on here. And this has got little buttons that you can enter. Rich in harmonics. It goes well up into 10 gigahertz. So I was setting up testing antennas 100 feet apart with just these as a transmitter. They've also got a little logarithmic power detector that you can hook up right there. It's calibrated up to 8 gigahertz, but it'll go to 10 uncalibrated and give you a linear reading. So you can build your own power meter or detect it and put it on your computer and use that as a display. And they even make a little power meter that's got a built-in LCD screen. And this one will go down to minus 60 dBm and up to like plus 10. Wide dynamic range on that. And this stuff is so cheap. Speed pack from China. China. Another way that is affordable is a company called Down East Microwave. They used to be up in Maine. I'm not sure if they're there anymore or not. But you can buy a transverter kit. And this is the kit unassembled. I bought this about 3 or 4 years ago. I haven't had a chance to put it together. It uses pipe cap filters. You can see the little copper caps that you can go buy at Lowe's or whatever and make your own. It's got a little Teflon PC board. You can pass that around. And this is the location for your copper pipe caps. You're supposed to solder them on. It costs about another $100 to have this thing assembled. I wish I'd have done that. I'm saving myself. It's still 3 years later, it's not put together. Once you start building it, you're committed. You gotta go on. You gotta solder those pipe caps on. You gotta put in the little, it gives you the little, they look like tiny tacks that go in there, and they're the 1/4 wave inch probes that go inside of it.
Too much wattage to heat those caps to it, or those metal pipe caps?
But it's really, really affordable. This is their website. That particular one is an upper lift up there with the minimum components, the circuit board, the minimum components, $195. That'll get you, with some kind of outboard radio as an IF, just practically anything. The FT817 Yaesu or the ICOM or anything else as an IF. And you're talking all mode on 10 gigahertz, 10 milliwatts. I see someone on eBay that's got a, I think it's a 3-watt amplifier for 175. That's pretty reasonable on there. And then find yourself a little relay, microwave coaxial relay. You may have to pay $50 or something like that, either 12 or 24 volts. That's not so much of an issue. But that'll get you on there. Up to this point, playing with ham microwave has pretty much been a homebrew world. If you're going to do it, you're going to either put together a kit or you're going to scrounge the components and put it together for yourself. Like this, we haven't made any measurements on this yet, but a lot of people taking the Dish Network, DirecTV antennas that the people toss out on the street, and they're perfect reflectors. I think you're going to mount one like that little down converter. That'd be for receive only. Onto one of these things, you got to figure out where the focal point is. It wouldn't be hard to do if you've got the feed horn, because all you need to do is stretch a wire, down inside there and use that as your measurement. What I've tried to do here, and again, the jury's still out. We haven't made any measurements. The domestic satellite system uses circular polarization. Here in the ham world, we don't. We use linear polarization. And so it has like a little aluminum ridge on the inside that takes and converts the circular polarization to linear. Well, I took all the guts out of it and chucked it on my drill press with a step drill bit and drilled all the way through it. It's right at 7¾ of an inch diameter. Drilled it all the way through. Put a pipe cap in there with a quarter wave piece of coax soldered into it and coming out to an SMA. We'll see how this works. It might be a little small for 10 gigahertz, but we'll see. Otherwise, you can buy the bracket, the little brackets that you see that thing mounted on. You can buy those, or $10, real cheap. And a dish like this will give you up to 30 dB a gain. I mean, the best DX I've had on this antenna was 23,000 miles away, picking up a a Dish Network satellite. So you can imagine the gain and how sharp the thing is. But getting away from that, ICOM has come along and changed everything. For people that didn't want to put the kit together or scrounge everything to put it, they came out with a microwave radio that all you have to do is take it out of the box and turn it on. It's pretty amazing. They must have put a lot of thought into the thing, because being a microwave radio, you don't want to run 100 feet of feed line of any kind. Even waveguide is starting to have some loss. So they decided to design the radio where it will go at the top of your tower, and with extremely short runs of feed line. The radio itself is powered off 48 volts off a Cat6 cable, like power over Ethernet. Now, this is not a radio. This is what we call control head, but it's got a lot of stuff packed into it. This converts 12 volts to 48 volts to power your equipment, and basically acts as a digital IF. This box is the actual radio, and it has multiple ports. The type in connector right here will give you 10 watts at 2 meters, 440, and 1.2 gigahertz, 10 watts, all mode. And by all mode, I'll be demonstrating that in a minute. You've also, and this is part of the secret, right here is a little antenna, GPS. receives GPS and provides the ultimate frequency, stability, and accuracy once it locks onto the GPS. It has 2 SMA ports on the top. This is the stock radio, 5.6 gigahertz and 2.4 gigahertz, 2 watts on each band. With that, with the optional 10 gigahertz module, you come off of the 2.4, it's now the IF for the 10 gigahertz. It has its own SMA connector for 10 gigahertz, and the 2.4, because there's a relay in there that switches it in and out when you want to play 2.4. Let's see, it does single sideband, it does FM, it does D-Star. So if you want to send data, text, pictures, or whatever, it'll do that. It'll do amateur television. And that's all built in. So I guess they wanted to cram all these features so that, you know, if you're going to spend that much on the radio, you're going to get a lot of features to go along with it. The basic radio costs about $3,000. The 10 gig module is an extra $900,000, something like that. So Lawrence couldn't stand it. I had one, so he had to go get one, and he had it set up on this speaker stand. So he was nice enough to sell me his speaker stand, and he went and bought another one. This is a really nice way to set it up, because then you could just slide it out, carry it in one piece, fold up the stand, and you're back in business. We can demonstrate the different modes. I believe we're on 1296 FM right now. Like the other ICOM radios, the screen goes to sleep after a while. Oh, I hope my battery's not run down.
Nope, it's working.
No, I think it's restarting. Come on. Okay. 1294.5 FM. And I believe we got that on channel 60. Is that what you're on, Johnny?
I think so.
All right. We got a 10 dB attenuator because we're awfully close to each other. KE5O, test 1, 2, 3.
N5 NED test 1, 2, 3.
It'll do FM. You can also get an Alinto 440 and 1296. 200 something bucks. Very affordable. KE5O. We can stay on the same band and go channel 50. Amateur television. Let's see, push menu, video is on choice 2. Got a little bullet cam right there. It'll display your transmit video on the screen as well as your receive video. Oh, got to turn this on. It also has an AV output. So, you on ATV? Channel 50? Yes. Go ahead and key the mic. You keying it up?
What frequency is that?
Should be 1294.5. Oh no, wrong band. 1275. Channel 50. Yes, sir. Right now we're above 1 gigahertz right now. The antenna is this mobile whip right here. It's FM video, and there you go. Yep. Okay. You can also watch on the screen right there. Go ahead and transmit, Johnny. It'll show the picture right on the face of the rig, right there. So you can tap on the screen again, and it'll provide you both your transmit and receive video. With an AV output, you can put it on a big TV set. So it'll give you that mode on all those bands up, 1.2 gig up to 10 gig. We don't have antennas hooked up right now for 5 gigahertz, but we can jump up to 10.368 FM, which is channel 63, Johnny.
Yep.
FM. And this KE5O.
N5 NED.
Yeah. This is without, we're in a metal building, so you can forget the GPS. This is just the frequency stability of the radio out of the box. It's pretty good. It's so good, in fact, that let's go ahead and switch to sideband. KE5O.
N5 NED.
It's that stable at 10,000 megacycles. So, pretty amazing. Let's play ATV at 10 gigahertz. You just change the modes, just like on a 7300 or whatever. What radio is this? This is an ICOM 905. This is the actual radio. This is the control head. You can have them up to 150 feet away, up on a tower. On there. 10 gigahertz ATV. You picking me up? Oh. Let me turn this off. And there you go. Gut-wrenching 500 milliwatts of power. And with dishes, we could do this over 20, 30 miles. So, unfortunately, us being flatlanders, we don't have a lot of hills and stuff to go to. But there's other things you can do. Lawrence and I have tried water tower bounce. Let's see. I set up about a mile away from his house, and this is in his front yard. That's that 705 with the little converter, and he's actually holding a receive converter, and behind that tree is a water tower, this house. I'm about a mile up the road. With my setup, it used to be on another tripod with that horn. And if you look at the very top of the screen, you'll see what I'm aiming at. You see the water tower? And if I moved off of it, it went away. It was working. We want to get dishes on both ends and bounce between two water towers and see if we can make that work. I'm pretty certain that we can. But what some of the other people are doing, and I found this fascinating. There's a column, this guy writes in QST. It's intermittent, it's not every month, but he's got a column called microwave links. Here's one where he's describing the little power meter, and he puts it in a Sucrets box, Altoids, with a little bar graph meter. And he's also demonstrating the little tiny SA Ultra. This was a column about a year ago in QST. And what I was getting at was these guys are operating rain scatter. So you've got a thunder cell, it's up around 50, 60,000 feet. And there's a website you can go to, rainscatter.com, and it will show you everywhere that there's a big thunder cell. And it will calculate the range between you and another ham. You can both, and you don't have to be a direct in line. You both are aiming at the rain shower, and the raindrops are dispersing your RF, hence the scatter. And you're able to communicate up to like 700 miles away with just 10 watts of power at 10 gigahertz. It's a lot like moon bounce. There are people doing moon bounce with powers very low, using slightly larger dishes than that. They're doing 10 gigahertz moon bounce, and yeah, and being very successful. You know, they're running like FT8 and things like that. But anyhow, yeah, here's where you can see a straight line distance between those 2 points. The one guy is in Fort Wayne, Indiana, and the other guy is up in Minnesota. And they're both aiming at the same rain tower and making a contact. Here's one, it's 555 miles apart. What you got to look for is that the line you're going to be shooting across the line. If the line of thunderstorms is between you and him all the way across, well, you can forget it, because it's going to soak up all your RF and you'll never be able to do that. But you want to shoot a tangent across the weather front as it moves through. And there's a guy, he's using a flex radio as IF, and that's the signal he's receiving. It does disperse. You lose the tonal quality of the CW note. You're operating CW. And it sounds like on-off noise. But it's Morse code. You can copy it. You can actually see it on the waterfall display and actually see the dots and the dashes on there. And they're, this is a guy at the other end. I don't know how many hundreds of miles away they are. But he's got the ammo can when he's got his transverter in it, and he's got the ICOM 705 as the IF. There's his setup with the ammo can and the dish, just like that. And you can see the feed that he built. It's just a little pyramidal horn, like I showed you over there. And these guys, I think they might be running 3 watts, 10 watts. Extremely low power. And they're working hundreds of miles apart. Of course, he's up on a hill, so that helps aim for the horizon a little better. And this is the number of grids this guy in Fort Wayne has worked on 10 gigahertz. Everything that you see that's green, he's worked all those grids on 10 gigahertz. And it's pretty much, it's amazing to me. Okay, yeah, that's all of that. But see, you can go to that website, rainscatter.com. This is live and right now. These are all hams where the push pins are. And you can see there's not a lot of weather going on right now. Up around West Virginia maybe. But again, this is real time. You can zoom in and it will plot between, you pick 2 push pins, and it'll plot the distance and suggest a rain shower for you both to aim at on there. So it's not so grim that we live in a flat area. There are other things that you can do. Yeah, most people do, like in Europe, they go hilltop to hilltop, mountaintop to mountaintop. And they play more with microwave. The British and the Europeans play more with microwave than we do. I think ICOM is selling a lot more of these radios over there than than they're buying here. But anyway, that's pretty much all the features of the radios and all the little show and tell that I brought. Does anybody have any questions? That or historical questions or whatever. It's been fun. I think we're going to have a lot of fun with the radios as time goes by. But anyway, appreciate y'all all coming, and think about joining with us. It's real cheap to receive anyway. Yeah, less than $100. Thank you.
Thank you.
Thank you.